Welcome back. Now we have a weapon, and we can pick it up and everything is great. But we used to have this weapon floating up and down using sinusoidal movement. And if we go back to our Blueprints, Items, Weapons folder, and open BP weapon, we'll see that we used to have add actor world offset, and this was connected to the tick event. Now, if we connect this again, we see all sorts of problems when we equip the weapon. I'm going to go ahead and pick it up, and you'll see that it's still oscillating up and down. And that's not great. We'd like to have that floating movement, but it needs to stop as soon as we equip the weapon, which means a weapon kind of needs to know if it's been equipped or not. And that's why enums are so useful. We can have a state for the weapon. Now, a weapon is a class that derives from item, and we can remind ourselves of that by taking a look at our weapon header file. It's a class based on a item, and we might want to be able to pick up multiple types of items, not just weapons. We may wish to have some sort of health pickup. So the concept of an item state shouldn't just be restricted to weapons. We should have some sort of variable on the item class, and the weapon can inherit that and use it. So I'd like to go to item.h and define an enum here that we can use for the item's state. So we can declare a scoped enum. So we can say enum class, and we can call this eItemState. And this will determine what's possible for an item, whether it should be hovering, whether it shouldn't be hovering, and so on. And we can add states here. Now, I'd like to also make this a uint8, as that's a pretty good habit to be in. And now we can add individual constants to this item state enum. Now, these enum constants will start with EIS for eItemState. And we can have an initial item state for any type of weapon when it should be hovering. So we can call this EIS hovering. And we can have another item state for whenever we equip the item. So we can add EIS underscore equipped. So we have two enum constants, and we're not exposing this to Blueprints. Later on, if we decide we need to access this type from within Blueprints, we can. But we're not going to overexpose to Blueprints. We're going to expose it when we need to. So I'm going to leave this as a raw C++ enum, and we can add a variable of the type eItemState to the item class. Now, the item class is going to have this variable, but we're going to use it from within the weapon class. So for that reason, I'll make it protected, and it won't be accessible from outside the class, but it will be accessible from child classes such as the weapon. So I'm going to make an eItemState called itemState. Now, we can't give this a U property, as this is not marked as uenum up here where we declared it. And as I mentioned, if we do need to expose this to Unreal Engine's reflection system, then we'll add the uenum macro to the itemState enum. For now, we're just going to keep it in C++. Now, we can give this a default value. I'd like to give it the default value of eItemState hovering. So all items will start out in the world in the hovering state. And we can check this enum before we start hovering in the tick function. Now, we are implementing add actor world offset here in Blueprints. I mean, we're not really because it's not connected, but we were before. But we can do this in C++ instead. So let's do that in the item CPP file. So we'll go to item.cpp, and in the tick function, we'll scroll all the way down here to tick, and we can do what we were doing in Blueprints. We can use the transformed sign function, transformed sign, which returns a float, and we could store this in a local variable, const float. We can call it z, and just like we did here in Blueprints, we can call add actor world offset. So if we call that add actor world offset, we can pass in the vector that is our delta location, and that's going to be an f vector with 0 for x, 0 for y, and z for z. And the rest of these inputs could be left to their default values, so I'm going to leave it at that. Now, z is not very descriptive, but in this case it does make sense. Alternatively, we could simply take our call to transform sign and pass it straight into the f vector constructor here. And then we don't have an intermediate variable, and this is pretty self-explanatory here, so we could do it that way as well. Now here's the thing. We only want to add the actor world offset if we're in the hovering state. So we can place an if check here. We can say if item state equals item state hovering. And we can place our call to add actor world offset right there inside the if check. Now, if we ever set our item state to something else, such as equipped, then we'll fail this if check and stop adding a world offset. So the question is, when should we set this item state? Well, in our weapon class, we have an equip function. Let's go to weapon.cpp and take a look. Here's the equip function. And in the equip function, we're attaching the item mesh to the component passed in. And we're calling this from the character class. Well, as soon as we do this, we can set the item state to equipped. So we can say item state equals item state equipped. And once this happens, the items tick function will fail this if check where we're checking to see if it's equal to hovering. It'll now be equipped and we won't get that sinusoidal movement anymore. So we can save everything here and hop back into the editor, and we don't need these nodes anymore. So we can remove that, and now our weapon has an empty blueprint. Let's go ahead and hot reload. So now that we've hot reloaded, we can go back and press play, and we do get sinusoidal movement. The weapon is hovering, but as soon as we press the E key, we now have the weapon equipped, and it's no longer using add actor world offset. So we got what we wanted. Perfect. Now before we wrap this up, while we're still on the concept of preventing things based on states, we have our attack animation, and we're still able to move around while that animation is going, and that results in foot sliding. And that's not very nice, so I'd like to prevent us from being able to move while we're attacking. So for that, we can head back into /character.cpp. And the reason we're moving is because of our move forward and move right callbacks for our axis mappings. Now, we don't need to move forward if we're attacking. Now, yes, there are games where you can run and swing a sword at the same time, and that involves different techniques. For now, we're just going to stop moving while we're attacking, and to do that, we can simply place an if check here. We can check our character's action state. Remember, in character types.h, we have action state with unoccupied and attacking. So what I'd like to do is make sure we're not attacking in our /characters move forward and move right functions. So we can say if action state is equal to action state attacking. If we are attacking, I'd like to return out of this function early, so I'll simply place a return here. And then the rest of these lines won't even be reached as we're exiting from the move forward function. I'm going to take this check and add this to the move right function as well, and now we won't be able to move while we're attacking. So I'm going to save all, jump back into the editor, and hot reload again. All right, so we've hot reloaded. Now we can grab a weapon. We can attack while we're running, and we stop running for the duration of the animation. And that stops us from sliding our feet. Now, yes, there are ways to run and attack, and also some attack animations bring the character forward. They use something called root motion. And those are all different techniques. For now, we're just going to stop moving while we swing the sword. We have to take things one step at a time here. And now that we're not sliding, things are looking a lot better, they're feeling a lot better, and we're ready to start moving on into more interesting things, like actually hitting something with our sword and causing things to happen. And we'll get to those things. Great job. I'll see you in the next video.